Live from New York, it's Ask Us Engineer.
Hey everybody, and welcome to Ask an Engineer. It's me, Lady Ada, the engineer. With me, Mr. Lady Ada on camera control. You got a jam-packed show for you tonight, with all sorts of new products and videos and coming out and INPI and like images of the Vegas sphere. And Phil's gonna go on a rant. It's so
I
exciting.
got a glass head.
And there's a glass.
Because it's green and we have a green screen.
Oh,
That's cool.
cool. It's
Yeah,
translucent.
I'm in my Abyss James Cameron phase.
Yeah.
Like,
You love the spheres, and you still love the spheres are
yeah,
freaky.
look at this. Okay.
Freaky spheres. Okay, well, let's get right into it. What's on tonight's show? What's the code? Sphere.
Tonight's show, the code is Cutie Pie Audio, 10% off in the Adafruit store, all the way up to 11:59 p.m. tonight, or when I remember to turn off the code. Spend some cash, save some dough, get some free stuff, use the code. We'll talk about from Disc LadyAda. Every single week we do a recap of what was on Disc LadyAda, our live show that we do over the weekend from LadyAda's desk, including the Great Search. We got JP's product pick of the week. Time travel, a little bit of news, Vegas news, actually. And then I'm going to do a segment about some open source hardware. Release an article today. That's that glass that I just showed you. Talk about current state of what's going on with some open source hardware companies and more. Tune into that. We're going to do some advanced manufacturing, made in New York City factory footage, some 3D printing videos, some INPI this week. It's Infineon, brought to you by DigiKey and Adafruit. We're going to do some top secret. There's a bunch new products. We're going to answer your questions. We do that on Discord because there is a lot of places that we're broadcasting. Adafruit.it/Discord. Put your questions there, either throughout the chat or just hold them to the end. All that and more on, you guessed it, Ask an Engineer. So, first up, LadyAda, let's make sure folks know where they can save some cash. That's with this code. That's here data for Cutie Pie Audio. They get free stuff. What did they get when they start spending some bucks?
We have all our freebies enacted. We've got the half-size Perma Proto that you get for free when you order $99 or more. We will be phasing this out for something different soon. So if you still want one, pick some up or order more than $99. $149 or more, you get a free black KB2040. We ran out of the pink PCBs. But I got Adafruit Black, looks cool. It's got that gold plate castellated pads. It's Pro Micro pinout compatible and features an RP2040, so it's great for any kind of microcontroller project. Free UPS ground shipping for orders over $199. We'll talk about that in
Who knows how long that's going to last? By the way, there might be a UPS strike. We have FedEx coming. Don't worry. If needed.
This is only
who knows?
We have UPS.
Yeah, uncertainty. Ground
and $299 or more. We've got Circuit Playground Expresses, lots of them. Thank goodness. So our favorite all-in-one development board. Okay. It's round. It's got LEDs, buttons, sensors, and everything. Works great with Arduino, Circuit Python, MicroPython, Code Discoveries, and more.
So them's the free stuff, and don't forget the code gets used with that.
Free.
And then today, I got to spend some time on this. This is
it's special day
for all who celebrate. Yes. Today is Prime Day, and I just wanted to say thank you for Optimus for making the ultimate sacrifice. It's great that every year people get together and honor Optimus and the great thing that he did. There's all sorts of events and more today. It's a solemn, sad day. Hug
your robots.
Thoughts and more to Optimus's family and friends, but Prime Day. Okay. That was just a joke. Please buy stuff from Adafruit because it's not Amazon. Anyways, show and tell. Thank you, JP, for doing the show and tell. I did get a little glimpse of it. We're going to watch it right after because we were doing all this show stuff. There was a really cool Cutie Pie synth thing that Toddbot did.
Yeah.
And I just saw a glimmer of it. So I'm gonna.
Glad the code's Cutie Pie.
Yeah, and I think Mouse came back with some synth stuff, and then DJ Dev had a cool project. So I gotta see that. But that was right when we were about to start the show, and we were kind of like trying to get everything done at once. Next week, Liz will be hosting, and then we'll probably be back. So every week, 7:30 p.m. Eastern time on Wednesdays, show and share projects, retro stuff, just about anything. It's the longest running show and tell. Come on by. Sundays we do from Desk of LadyAda. What was on your desk this week, LadyAda?
Okay, well, first off, we built a second toy hacker board. You spray painted it purple for Prince, and you put some Prince tunes on it because there's like a release of some Prince
Yeah,
all of
we're
iTunes.
we're gonna in the top secret section. We're gonna show a preview of the first only Wi-Fi Python open source music streaming player for infants. Ours plays Prince, and we modified the inside and the outside.
Cool. Also showed off, let me see, I got a couple of things going on there. The toy hacker board is for signups. I showed off this board that plugs into a Raspberry Pi and lets you connect to iSpy or Stomach UT and has some buttons and switches. You designed it actually with me because you were like, let's make it easy to plug in hardware to a Raspberry Pi. And then I finally got some ICN 6211s back in stock. They're available. You can buy them. And so a design that I started in 2020 or 2021, this ICN 6211 DSI to parallel display is coming. I made one mistake on the board. I talk about that, but also thankfully, even though I swapped two pins, we can bang I2C on CircuitPython. So I did get the register reading coming back. And also I showed off some cool flexible PCB prototypes I got.
Okay, then we do the great search. That's when you use your powers of engineering to find things on digikey.com. What did you look for this week?
So this week we showed off a board that has a USB hub chip on it. It's a very simple USB hub chip, but you might want a slightly more advanced and powerful USB hub chip. And actually, somebody emailed and they said that they were using this chip they ended up finding in a design because they wanted a hub that they could control, turn on and off the power ports remotely. I think this chip does that. So we look at different smart USB hub chips that are available, 2, 3, 4 port. There's like 3 or 4 chip companies that have like a big family of them. But they're definitely nicer than the really inexpensive ones. You have LED control, overcurrent detection, voltage, turn on and off, change the VAD, PID, descriptor strings, swap ports around. You can do a lot of cool stuff with these hubs over I2C control. So we found a family of chips you can check out from Microchip.
Okay. And then every week, JP does a product pick of the week. JP's back from vacation. This is a live stream from a product page where the discount is automatically applied. Take it away, JP. This is what this week's highlight.
It is the PAM 8302 Stemma audio amplifier. It's a mono 2.5 watt amplifier, and it is pretty plug and play. You can see here I've got a little speaker here plugged into the screw terminal, and then we have a little Stemma 3-pin plug that you can plug into your project and get the audio power and ground reference over to the board. So I'm just going to power this up over USB. Let's see, I can adjust the volume down and up.
0, 1, 2, 3, 4, 5, 6, 7, 8.
It is the Max 8302 Stemma audio amp.
Okay, a little bit of time travel. By the way, this week's show is going to be different because we got a lot of different segments this week. So we're going to have some that we're going to spend a bunch of time on, and then, of course, some we'll just do next week. But I did want to get some news out. So coming up is DEF CON Vegas. DEF CON Hackers with Disabilities is one of the groups and more. We are a sponsor. On Saturday, there will be trivia prizes. You can win Adafruit gift certificates and more. The folks who run it contacted us and they said, hey, we want to have some cool things to give away. And so we worked with them. And that reminded me of this Vegas footage that's going around right now. This is this giant LED ball. And I'm just like, oh, cool. Phil B's going to run his eyeball code in this one day. But
It is one eyeball code.
yeah,
It's
but
cool.
the thing about this was I'm like, I wonder what this really looks like in person. Is this like marketing shots or is this something? So Maker Melissa is in Vegas. And I said, hey, can you take some footage, just like whatever, during the day? And so this is during the day footage. This is LED.
That's bright.
Yeah. And we're not really sports ball folks, but I understand this is basketball, of course. And this is really, really neat. I would go to Vegas just to see
Well,
this.
to DEF CON, this is like a cool thing to go check out.
Yeah, and just look at straight up daylight. This is
Yeah.
what,
And Vegas gets bright. It's hot and sunny and bright.
yeah,
there.
this is like full on, the sun is closer to this portion of the planet and it still looks this bright. So you can see. I thought this was neat because I didn't really see anybody post footage like this online, and thanks to Maker Melissa for getting this to us because I'm like, I wonder how good it looks. But this is really neat. I want to see this. So it's electronic related.
We
So,
go to Apex Expo,
Yeah.
Vegas again.
okay, and then some open source hardware guide stuff. We're not going to do the full on guide, all the guides we do each week.
Yeah.
But we are going to do one because I wanted to play Liz's video. If you have one of these IKEA air quality things, you can hack it with a QT Py ESP32 S3 and Adafruit IS. So go to our Learn system. You can see all the latest guides. We're going to go over all of those next week because we got a bunch of other stuff we're doing this week. But here's a quick video. So if you haven't seen it and haven't seen the guide, check out this little video snippet.
In this project, you'll add a QT Py ESP32S3 to an IKEA Vindrickning air quality monitor to convert the small and affordable PM2.5 sensor to an IoT device. Unlike most IKEA hacks, this doesn't require a hammer, just a soldering iron. It's also non-destructive to the air quality monitor. 3 exposed test points on the PCB are soldered to, and the QT Py is able to receive power from the built-in USB-C port. The QT Py runs CircuitPython code that reads UART data from the PM1006 sensor inside the Vindrickning. It then logs that data to a dashboard on Adafruit IO. You can set up alerts in Adafruit IO to text or email you when the air quality starts to deteriorate. See how you can hack your own by checking out the Learn guide at learn.adafruit.com.
Okay, this week is some open source hardware news. This kind of goes into the maker business. We used to do a specific like video show around this, and we kind of just merged it into Ask an Engineer. But we have an article. I have an article. Once in a while I write, and this is called. Oh, that was at Glasshead, by the way. That's how.
Yeah.
Yeah, that was a Glasshead.
That's me holding up the glass head.
Yeah,
We
this
wondered
was.
if people would think it was like Mid-Journey. It's not.
Yeah,
it's
it's not.
actually just a glass
No,
head.
this is real art that we made right
It's
here,
real
right here.
Right here.
So this is the article. You can get to it at adafruit.com/changing OSHW, or you can just go to our blog right now. So the title of the article is called When Open Becomes Opaque, the Changing Face of Open Source Hardware Companies. And this
Who wrote this article?
I did. Yeah, you can see it. We have the byline right here. So this article was something that I didn't really have time or want to write back in, I think it was March or May. Prusa, the best known 3D printer company, said, hey, we're not really, looks like we're not going to be releasing some of the open source files and open source stuff for our printers. And I was asked to take a look at this, and I'm just like I don't know enough of what's going on in that 3D printing world, but I'll try. And then Arduino got 32 million in funding, and they changed some stuff on their site, and I'll get into that, and also how they're doing some things with open source. And I was asked to look into that, and there was a product release from SparkFun that there was some questions about how they're doing open source, and I was asked to look at that. And so in this article, I kind of go over why in the world am I in this kind of unfortunate.
What do you care?
Yeah, why am I in this? and some of it's because I started Hackaday and I was at Make, and I was often asked to help navigate some of these issues. So one example is Scholastic took Evil Mad Scientists open source stuff and turned it into a book, and they didn't have credit. And Evil Mad Scientists is like, this sucks. We're not gonna like sue them or anything, but like we just want to get credit. So I was asked to like go behind the scenes and like try to help out.
You're here to throw back to liquidware.
Yeah, there was companies.
They said it was open, but it wasn't.
Yeah, there was companies that were selling open source, and so my strategy is to privately communicate with these folks and say like, hey, here's the open source definition. Here's the things that we try to stick to. Here's all the benefits of doing open source. I've kept track of this. So if you look, and I linked to all these things from like the first open source hardware gift guide when it was like 10 open source hardware projects. This is a long time ago. And then when MakerBot had its rise and fall with open source hardware, got into patents, got acquired and all that. So I've just been in this, and like this beat is in the article. I said this beat is I'm stuck with it, and it stuck with me. So I don't really have a ton of time to write articles, but there are like little checkpoints along the way that I try to have on our blog, and
Yeah.
it's great that we have a blog. I like that we publish. Social media platforms change, things go away, but we have a blog that's been around for almost 20 years soon. In fact, I refer to some previous posts on this article that is a follow-up. So this is essentially like notes to self.
Yeah.
So the thing that's changed with open source hardware is it looks like some open source hardware companies are starting to go closed source or change what they're doing. Arduino is now, I think, essentially like two different efforts. This is just my point of view. There's Arduino Pro, which is not open source hardware. I confirmed with them. They said, nope, it's not open source hardware. And I said, okay, but your site still says everything is open source. So the Arduino site had said all boards are completely open source, all the software is open source, and for us, this is this thing that we've worked on for a really long time. We have I think, still the most libraries. I think you're still one of the top contributors.
I'm definitely one of the top library. Maybe not like
And
new ones as of this year.
yeah,
I was on maternity leave, but historically overall, I think I have like 450 libraries.
so if you look in the article, because the site used to say all the boards are open source, all the software is open source, that's been completely removed, gone. And I had asked Arduino about this, and maybe it's coincidental, but that was the time I'm like, hey, it's like, what's going on with your open source stuff? So that got updated, changed. Arduino got 32 million in funding, and this article is on making the rounds, so some social media right now. No one knew it. It really, AI startups, like back in the day, crypto and NFT startups made the news. But Arduino getting $32 million, the best well-known open source hardware company, $32 million. That's a bunch of money. And the only one that I can think of besides this was Little Bits. And Little
like
Bits
40
was
million.
open source hardware.
Mhm.
And then they're, I think, just part of Sphero now, not open source hardware. And what seems to happen is when companies get investment, especially this amount, they stop serving the users and they start serving businesses. So this seems to be an indicator. So with Arduino, they have the Pro version, the Pro stuff, and that's for business customers. They want to focus on business. And it seems like some of the open source stuff is not the same as it was. We'll see what changes. That being said, the latest Arduino R4 is still open source. Yay! So good on Arduino.
No, it's good.
Good on Arduino.
And I checked, the files are there.
Yeah, I did ask them. I said, hey, since like we're in this murky territory, it seems, where there's some Arduino that's open source and some Arduino that's not, would you consider open source hardware certifying the Arduinos that are not Arduino Pro? They said no. So that's their choice. I think it would be a good thing, but up to them. And I was asked about this because we were asked to carry it, and we're one of their products. And I'm like, oh, it's an Arduino Pro. And then we were asked to carry another product, and I'm like, let me ask them. And sometimes I get a response, sometimes I don't. SparkFun, this is the one that came in recently. SparkFun, the OG, we wouldn't be here, I think, unless SparkFun did what they did. And I think this is the first time they've had a product that has closed source binary file. And if you want to get the software, you have to sign an NDA. A person wanted to use the product for, I think, their company or something. They said, do I need to rewrite the software, or like, can I take a look at it? And the SparkFun person said, we are keeping the data logger firmware closed source as it contains SparkFun intellectual property and is the result of hundreds of hours of work. We may be able to release to you, but it would need to be under an NDA. Now, the SparkFun board has an open source hardware logo. It has a CERN license for the hardware, software license MIT. I asked them about it, and they said that was an error because obviously you can't say it's open source when you have a closed source binary and an NDA. I think that this is the first time they're doing this. Maybe they're experimenting. We'll see what happens.
I'm not aware of any others.
Yeah. So I was asked, hey, do you know about this? And I said, well, I'll just email SparkFun. And SparkFun CTO got back to me, said it was an error that the board was marked as open source with the logo and certification. And I said, hey, I'm kind of curious, is there GPL software in that closed binary, or is there any open source software in that closed binary because it's like an IoT thing. It's a data logger IoT. You can use open source software in closed source things with NDAs. I would like to know if there's any in there. I understand. I'm not going to sign an NDA, so I'm never going to know. So they didn't reply to that one. We'll see. If they do, I'll update the article and I'll put exactly what's in there. And then to get back to kind of the beginning, Prusa, they're still selling a board or boards that have the open source hardware logo, and the product pages still say it's open source. People are buying these things that are open source. Prusa has an article. They're like, hey, we're thinking getting out of open source. They have a whole list of reasons, but then it kind of went on radio silence after they posted this article. And then Thea had a article about like, hey, here's what's important to open source, and maybe there's solutions to this. Michael Weinberg, who's I think president of the board or chairman of OSHWA, said, hey, like, what are the things that you're trying to protect with this new license? Prusa's idea is maybe there's a new license that can protect it. I don't think that's possible with hardware. And there's nothing that a new license would stop some of the things. Like they have a supply chain issue. They had went into some things about China. We have all the same things. I don't think that's the strategy that's going to work out. I think you just have to move really fast, give more to the users than you're getting. And with 3D printing, you probably have to have something on a regular basis that's lower cost and better. I don't know if it's open or not matters in the 3D printing world. Same thing with our stuff. We kind of have to have cutting edge stuff because there's like duplicates of our hardware. There's people who take our code. There's a lot of things that happen that you have to move fast. So this would be a little bit of a blow if Prusa gets out of it. On our blog 10 years ago, I wrote about Prusa's tattoo because I'm like, oh my gosh, you got an open source hardware tattoo. So you got an open source hardware tattoo, and I followed up with Prusa and I said, hey, like, can you comment on your article? And they didn't get back to me, and then they get back to me. Yay, thank you. And I got a comment. So they went into some of the reasons they're thinking of getting out of it. And then I also asked if he's gonna get rid of this tattoo because that's a pretty big tattoo for something. And it would be a sting, I think, to the community if Prusa exited the field. So maybe support them with their purchases. But I understand for our community, if you're not getting the files and the software and all that, you probably don't. You may as well get a closed source printer. You buy things for a reason. They have a really good section on why open source matters. Prusa himself said they wouldn't be there without building things on top of RepRap. So we're in this like beginning of the end or end of the beginning. Who knows? If you're buying things that say open source and they're not, and you return it because of that, should you get a refund? There's a lot of things. Cory Doctorow has an article about how platforms die, and I think there's a little bit of that with some of the hardware platforms. Once you start serving businesses instead of users, it seems like people will just leave. I look at our show and tell, and there's people that come on our show and tell for years. The reason they like going into our GitHub and the open source community is they know there's not going to be like a rug puller or switch, where they know that the code that they use, all the things they're doing, are not going to be wrapped up into a closed source thing and called like pro, or like they know where it's going to be used, and there's no shaky ground. And so we'll see what happens. It's definitely a different chapter coming up ahead. I think the supply chain shortage really put a squeeze on companies. I think they're making decisions. I think these companies are starting to blame open source. It's not open source's fault when you can't get chips from ST for years, or when someone comes along and moves faster than you. It's not the reason. And then, hey, we want to recoup money. Well, Adafruit spends millions of dollars a year funding open source. We're not approaching it in a way that's like, well, let's get our money back first and then put it out there. That's not the way it works. And also, there's really no protection for hardware. You can have patents, you can have copyrights, you can have trademarks, but there's no magical license. And this keeps coming up. This came up with MakerBot and came up with other companies that said, well, we want a license that says like we can keep it closed source until X, Y, and Z, and the license not going to do that. So we'll see what happens. I got some comment back from Prusa. We'll see if I get anything back from any other entities. This is probably one of 50 articles I've done over the last 20 years that has like, here's where open source is now, here's where it is later, here's what's happened, here's what open source hardware, here's what's changed. I remember when there was 3 projects or one or 2 projects that were called open source hardware. Now there's too many to count. And now we'll see, is the pendulum swinging the other way? So that's my article. I also put a disclosure. So when I was finished with this, I put all the text into ChatGPT that I wrote the text, ChatGPT didn't, and I said, what titles make sense with the context of this? So it spit back some other titles, and then I go back and forth. So it helped me decide on a title. And I like to do, we have an editorial guideline thing. Anytime we use these tools, I do that. I'll always put a disclosure, but anyways, I made this graphic myself, and the title, I had a computer talk to me about it.
I think it was a good one though. I like when open
It's
becomes
awful.
opaque. It's a nice.
Yeah.
That's a nice. Not all the suggestions it had were good, but this one I think was good.
Yeah.
But then a human picked from the suggestions.
Yeah, I was human.
Yeah.
Okay. Here's some factory. Speaking of open source hardware, here's some factory footage. And that's the factory footage. Someone in the chat said cat GPT, where
Yum, yum.
that'd be funny if it
Yeah.
analyzes your article and just goes meow 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 meow.
Meow,
Okay,
meow, meow, meow.
let's do some 3D printing videos and more with another picture.
You can build your own Adabot with Adafruit's RP2040 Prop Maker Feather. This is a fully 3D printed toy robot that features a servo-controlled head, sound effects, and NeoPixel LEDs. The startup sound lets you know when it's on, and the button on the back lets you play random audio files.
Well, pleasure to meet you.
The mouth lights up while the audio is playing, and the NeoPixels are animated when it's idle.
All systems are fully operational.
The head also randomly moves back and forth. To stop the servo, just lay Adabot on its back to go into sleep mode. This uses an accelerometer to detect its orientation. The mouth also slowly fades in and out, kind of like it's taking a nap. Powered by the RP2040 chip, this feather has everything you need to make simple robots, toys, and cosplay props. It's got all the features you know and love about the feather, plus an iTwist amplifier, accelerometer, NeoPixel driver, Stemma QT, and USB-C. We think it's the best all-in-one dev board for making these type of projects. Libraries for CircuitPython enable you to develop projects with NeoPixels, servos, and audio output. The code is easy to modify, so you can customize the LED animations or add new features. You can check it out on GitHub, links are in the description. We think CircuitPython is the best way to get started with DIY electronics. Download and 3D print the parts in your favorite filament. They print without any support material, and most of them snap fit together. The electronics are secured to the various parts, and they're easily accessible. It's a modular design, so you can swap out the parts or customize the design. To learn how to build your own, head over to the guide at learn.adafruit.com. We took Adabot on a trip to Star Wars Galaxy's Edge at Disney World and went to the Droid Depot to hang out with other robots. We had a lot of fun taking it out, and even more so, making robot friends. We hope this inspires you to check out the Feather RP2040 Prop Maker for your next project.
And before we go into INPI, don't forget the code is Cutie Pie Audio. Here we go. INPI brought to you by DigiKey and Adafruit. This week is Infion. LadyAda, what is this week's INPI?
Okay, this week's INPI is from Infineon, which I don't know if we've covered them before. It's this 14-pin SOIC chip. I want to get the part number right. It's the XDP2201. It's a hybrid flyback controller. The particular slash new, like the featured product on digikey.com/new was about an eval board they have for this chip, which we'll talk about more in a bit. And this board takes AC power from the left and it converts it to a high current DC power on the right for charging batteries. It's an evaluation board for large battery charging. It also features the Cool MOS MOSFETs with ultra low RDS on. It looks like they have a Cool MOS. They're so cool. They are in this AC DC converter. Bam, just like that. Well, there's only two of them. There's five in this particular image, but yeah, it's AC/DC converter chip that is a hybrid flyback and uses also Infineon MOSFETs and also does an eval board. So it's a 3-in-1 INPI. So what this board, this eval board, and this chip is part of is Infineon's full, from beginning to end, documentation and support and product line for light vehicles, also known sometimes as like micromobility or e-scooters, e-bikes, mono wheels, balancing scooters and stuff. And if you're like us, in New York City, you've probably seen a ton of these devices. E-bikes are really, really popular, especially over COVID 2020. In mid-2020, they were legalized. They were previously banned, but then they were allowed because so many people were doing delivery. They weren't using cars. They weren't using public transport. They were using e-bikes and e-scooters and skateboards and mono wheels. And so we see a lot of people with these battery-powered micromobility devices, and they're great because they don't have gas and they don't need parking. You can put them in your backyard, or you can bring them up to your apartment, or leave them outside the house or whatever and lock them up. You don't need to park them. You can just go in the bike lane. They don't go very fast, maybe 10, 15, 20 miles an hour. Just wear a helmet and you can zip around pretty quickly in the city. So they're very handy. A nice intermediate where you don't want to own a car, you don't want to get into a taxi, but it's a little bit too far to walk. But in order for them to carry you and your groceries and the 75-pound bike itself, it can easily get to 200 pounds. And so these things have really, really big batteries. They have about 250-watt batteries, maybe even more, 36 to 48-volt batteries. In comparison, this is a 10-amp-hour, basically 10 amp-hour times 3.7 volts. So this is, maybe a 35 watts hour battery, and the ones we're talking about here are 10, 15 times larger, and they tend to have they can have like 15 to 25 to 30 of these standard 18650 batteries. And you have to charge them very fast, and they have to discharge very fast, because especially as you throttle up and you want to kind of go up a hill carrying you and your bike and all your stuff, they're going to have to discharge a lot of current. And then, of course, to discharge a lot of current, they have to be very big, which means when you charge them, you have to have a big charger, and that makes them kind of dangerous. They are, very big, highly dense energy sources. And in New York City, especially, we've had a couple of fires from people not charging their batteries safely. So it's really, really important to pick and design a really good charger. If you're in a company and you are the electrical engineer, you're working on designing a product that uses these high density batteries, you want to make sure that you are getting your design certified. It's low heat, so it doesn't overheat. It's high efficiency, so again, less dissipation. It's UL certified. It's well heat sinked. It does a good job, and it plugs only one way into the battery, and it doesn't electrocute people. So there's all these things about batteries, but also the charger has to be well designed, and that's what this converter from Infineon is, and the eval board is all about, is how to charge these batteries. So, these batteries, you need to, again, they're 100 to 250 watts and they're 48 volts. So you need to basically have something that gives you mains power, AC, direct to DC. You're not going to be able to do a DC, AC to DC conversion and then boost up to get that wattage. You basically have to go straight to the wall. And because of that, you're dealing with mains power. So you want to be safe. You want to use something like a flyback converter that has isolated output. See that transformer in there gives you isolation, so there's no risk of the hot or the neutral accidentally touching the metal case of battery or the metal case of the bicycle, which could be very bad. Also, of course, sparks could cause fires. So having current limiting and isolation is important. But there's some trade-offs with flyback converters, which is that they tend to be really big and they're not good at lower voltages. They're good at like high voltages, especially if you want to boost up voltages. Here we're kind of bucking down. We're going from like 100 to 48 or 32, or maybe 220 to 48, 32. And so that's where we've got this design for a hybrid flyback controller. So this hybrid controller, what's neat about it is it's very small, it's inexpensive, and it's very, very high efficiency, 95%. So you get the efficiency that you would expect from your kind of standard DC-DC buck converter operating at its best input output optimized configuration. But this design is flexible about the input. You can drive it from 110 or 220, depending on whether you're in Europe or in North America. And it can handle different output voltages as well, which could be handy as you're charging this battery. The battery starts lower, it gets a little bit higher, or maybe you want to support different size battery packs with one PCB design that you just tweak the configuration. So it's a little bit more complicated than just a flyback, but what's really nice is that the chip, the XDPDS 2201 has all this stuff built into it. One thing, for example, it has the MOSFET drivers built in. It has a little mini booster inside that helps you drive both the high side and the low side MOSFETs. You don't need a separate driver chip for those really, really big MOSFETs. It does stuff like keep track of your zero voltage and zero current switching. You don't want to switch the AC on and off in the middle of a cycle. You want to do it when it does the zero crossing. And so this chip kind of does all that for you. So it's kind of got the simplicity of your, standard analog flyback or DC, buck converter, AC DC converter, but it's also got this enough smarts inside that it can give you stuff like failure codes out of a UART pin. It can also give you, you can program the configuration via this pin into a one-time programmable EEPROM for setting and fixing design. And it's been used in eval boards that they've created. They have a eval board for USB PD that can give you as little as 5 volts out to 20 volts. And then, of course, this version, which gives you 32 to 48 volts. I'll admit I'm not, a big power electronics designer. I didn't take that class in school, and I haven't done a lot of high voltage power design. But Infineon does have this really great webinar. Like, it's not a webinar, it's like a slideshow webinar, I guess. And there's a person who speaks, and there's a lot of slides, and they actually kind of go through and explain what's the difference between the flyback, your classic DC-DC converter, and this hybrid feedback. Specifically, what it's really good for is it's more efficient because not only is current stored in the transformer like most flybacks, or in the capacitor like most buck converters, but it switches between the two depending on whether you're at a low input voltage or high input voltage. And then the cool thing about this XDPS 221 is, of course, it can handle both.
Oops.
Sorry. This is the basic app note for the layout of this chip. You'll notice that you do need, transformers. You do need voltage into, you have to power the chip. And so you'll see that full wave rectifier. It's very low current power draw quiescence, like only like 25 or 50 milliamps, but you still need to have some DC voltage in. But then the output from, the primary coils go into the chip, which then controls these two FETs. There is an opto-isolated feedback input so that the output voltage is controlled, which is good because if you're charging a battery, you want to get it, close to the open circuit voltage of the battery, maybe a little bit higher, and then the internal charging circuitry doesn't have to burn off all that excess voltage as heat. And there's also these built-in parameters. So you can tweak the settings. The data sheet goes into all the settings of like your startup delay and like burst delays and, what inductor size, how much current and your voltage output, all that stuff. You can configure it with these parameters. There is a pin on there called the multifunction IO pin, and I guess it's asynchronous UART. They have a programmer dongle you can use to read and write it. And what's really nice is it also outputs failure codes, which is like kind of handy. This is a non-trivial power supply. If you're designing something that you're going to have people who are in a rush, they want to charge the battery and it's not working. Why isn't it working? Maybe because it's overheating, or there's a timeout, or a disconnection, or something mechanically goes wrong. You could probably have on your little charger at least an error code that tells people, hey, look in the manual, look on the website to see what is wrong with your setup, because these batteries and these chargers can be fairly expensive. Like I looked at prices of e-bikes and they're $1,000 to $3,000. They're not cheap. So the more information you give people, you don't want them to throw out the batteries or charge them unsafely if it's not a good time to charge them, if it's too hot or too humid out or too cold. Or if the voltage is too low, or you're getting an over voltage or over temperature. So all those outputs come on the UART mode, and then you would read them from a microcontroller and display them on an LCD or LED. And this is part of a big family of products. So Infineon does a lot of stuff for micromobility. They do the microcontrollers, of course, these FETs, the charge controllers, but they'll also probably do your motor drivers and such as well. So check out, they have like a gigantic section of their site where you can like go to each part of an e-bike or e-scooter. You want to design this sort of stuff, they'll hook you up so you can do it safely.
In stock.
That's right. These chips are in stock. They also have the eval boards in stock, but this chip in particular, the XDPS2201, you want to do something flyback style, high voltage AC to DC, this chip will probably do it for you.
Okay, I have a video, we're going to play it, and then we'll see you on the other side for some new products.
Introducing industry-first application-specific standard product based on asymmetric half-bridge flyback topology with Infineon's latest hybrid flyback controller, XDPS2201, to enable ultra-high-density charger design. It consists of a few major building blocks: a main stage and a PWM controller on the primary side, a rectification and communication protocol on the secondary side. XDPS2201 converts and delivers power over an isolated barrier in an efficient and safe manner. Targeted application includes smartphone charger, adapter, and USB PD charger. Bill of material savings and ease of design with an integrated high-voltage startup cell and high-side MOSFET gate driver to yield a potential saving of up to 20 external components. Multi-mode operation across varying load and line input conditions delivers high peak and average efficiency. Simplified and low-cost transformer design with a single auxiliary winding to support variable output voltage requirement. Infineon has developed a USB PD charger solution housed in an ultra-compact PCBA form factor. The solution supports a maximum output power of up to 65 watts, delivering a class-leading power density of 31 watts per cubic inch. As a leader in power semiconductor, the 65-watt solution incorporates CoolMOS, OptiMOS PD, communication protocol controller, and hybrid flyback controller XDPS2201 to deliver a high efficiency of up to 93.8% to miniaturize your next charger design. For more information, please visit our website www.infineon.com/XDPS2201.
Good new product is coming up. Cutie Pie Audio is the code.
New. It's not my birthday.
Not yet. Okay, first up.
Okay, we've got a bunch of updated products. This is the ESP32S2 Feather with a BME 280 barometric pressure and humidity sensor on it. It previously had an LC709203 battery monitor chip. That chip's been discontinued, and so we've revised it. It now has the MAX 17048, but luckily we've got great drivers for the MAX 17048 in both Arduino and CircuitPython. So it's going to be a pretty seamless transition. I think this might be one of the last boards that had the LC709. We've converted all of them over the Max 17, but people have been pretty happy with it so far. So good little revision. We've also revised these chunky 1.2-inch hide letter 7-segment displays. They have a 16K33 LED driver as a backpack. So we did enough of a revision that, because sometimes we put STEMMA QT connections on it and we're like, we don't really go through a revision note. But with these, one thing I did is they now have a little boost converter on the back, because these LEDs, the segments have 2 LEDs in a row. So you can't really use less than 5 volts. If you don't use 5 volts, you're not going to get the LED to light up very nicely. And so it gets nice and bright yellow, nice and bright red. And so now these have a little booster on the back, so you can use them with 3 or 5 volts, and they will boost the LED driver to 5 volts, but give you 3-volt logic level shifted on the expert C pins. So basically, it's just safe to use with whatever, and the LEDs will look good no matter what.
Next up.
This is coming soon, but I wanted to let people sign up because some folks were asking for the URL, and it's product 5778. This is the Matrix Portal S3. So the Matrix Portal is a popular board we made that has a 7051, and it uses an ESP32 as a coprocessor. But the 7051 has been nearly impossible to get. And so I was like, you know what? It's time to revise this board. Instead of having a 7051, the whole thing is now driven by the ESP32S3, which has a peripheral that makes it really easy to drive parallel displays like RGB matrices. So we're going to see how big of a matrix display we can drive with these. But one thing it has is a ton more RAM. It's got 2 megabytes of PSRAM and 8 megabytes of flash. So that's much more than the original Matrix Portal. And of course, it has native Wi-Fi. It also has BLE. Otherwise, it's the same physical size, has the same GPIO at the bottom, has the same pinout for the LED matrix. One improvement I made is, if you go to the next image, we now have, the next one. We now have it so you can plug in onto the back of the matrix on the bottom, like it sockets right in, or all the matrices come with a cable. You can plug the cable into the top. So it has some mounting holes. It's got a little bit more flexibility, but it should be completely code compatible in CircuitPython and Arduino. Maker Melissa went through all of our guides that use the Matrix Portal and made sure that they all worked on the Matrix Portal S3. Only one guide needed a little bit of hardware to make it work. Otherwise, all of them worked wonderfully. So I think it's going to be a nice little upgrade. So sign up when it gets back in stock. Next up, in stock for the first time. Last week we kind of showed this as a coming soon. This week it's actually in stock. It's the ESP32 S3 Cutie Pie. This version has PSRAM, 2 megabytes of PSRAM, 4 megabytes of flash, and yet it's so small. It's like the tiniest little board, but it's got this powerful S3 chip. It's a dual core Tensilica board. It's from Espressive, so it's got that Wi-Fi action really well. It's got Arduino and CircuitPython support. It's becoming a very stable chip. It usually takes about a year for a chip from Espressive to become stable and well supported by the IDF, Arduino, and CircuitPython. And I'm feeling like we're getting there. It's got 2 buttons, reset and boot, so you can get into the ROM bootloader, STEMMA QT port, and built-in antenna. We'll probably make a version also with a UFL for people who want external antenna. But the previous version we had did not have PSRAM. So probably folks are like, I need more memory. This version has a lot more RAM memory.
Okay, the start of the show, besides you, LadyAda, our community of open source hardware enthusiasts, people who are showing and sharing things all the time, our team, everybody who's making this thing go is
Angela. The Audio BFF. So this is a add-on board for STEMMA QT boards. We just showed off the ESP32S3 QT board. And those QT boards are very minimal. We don't add a lot of extra hardware on them because we figured, hey, you can just plug in little boards on the back. These are BFFs. And we made one that has a micro SD card, and we also made one with an I2S amp. And, I needed for a project something that had both a micro SD card and I2S amp so we could play audio clips, long ones that were too long to store on the internal flash memory of the S3 chip or the S2 chip. And so this is what I created. It's got a Pico Blade connector for the speaker. It's got a 3-watt I2S amplifier. It's by default, it's 9 dB gain and stereo mix output. And then there's a little Molex micro SD socket. You can plug in up to 64 gigabyte cards and then use Arduino or CircuitPython code. We've got plenty of both to read audio files or any whatever. It doesn't have to be audio files, although that would make sense because then you'd play them through the I2S amplifier and you get really good quality audio, much better than using a DAC. You're going to get, your full 16-bit audio. And then if you really want to, you can, of course, stack another one. I have 2 speakers. So maybe I'll show a quick
Yeah.
demo.
Should get in the overhead and I'll switch to that.
Hold on, I gotta get my. Hold on, where's my micro? I have to get my USB-C cable. Okay, so go to the overhead. So this is, yeah, hold on. It was out of focus, but now it's in focus. This is a prototype, so that's why it's got a little bit of a wire here. But it's otherwise the same idea. I just didn't. We just put these in the store like literally an hour before the show. So you've got your STEMMA QT. Your QT Py board, like this ESP32S3. Or you've got the this is RP2040, and then you're like, okay, but I want to have micro SD and speaker. You can solder headers onto this. And then what you can actually do is also solder this board directly. But in this case, I put socket headers on it. So I can remove it for live demoing. So plug it back in. And then let me reset it. Okay, good. It's running CircuitPython. And then it's the code I have on here right now reads WAV files from the SD card. And hopefully when I press the button, we'll play them out the speaker. So let's try it. So there's
We have noise cancellation going on, so it may or may not play exactly right.
This is Taylor Swift. Imagine Heap. Yeah.
Then on the overhead.
And works quite nicely. So you get really nice quality audio. And I prototyped this originally for the Toy Hacker board because I wanted to have something that could play long audio clips, like up to 2 or 3 minutes. And it works very nicely. CircuitPython is what we recommend because we've got the best I2S wave playback support there. But you can also use Arduino or ESP-IDF if you like, or whatever.
And that's the perfect. Okay, here's what we're gonna do. Some of y'all have been putting questions over in Discord. No, it's fine. Some of y'all have been putting questions in Discord. We got those.
Okay.
We're gonna get to those in just a sec. We're gonna do some top secret first, and then we're going to answer some questions, and then we're gonna eat. Let's do some top secret. Okay, so we're going to play 1, 2, 3 videos, and then you're going to show 3 things that you're working on. Some of these things are part of our new products tonight that you were doing some testing on, whatever.
Yeah,
and
we
then
want to see behind the scenes.
and then we're going to show you some of the stuff we're working on. So here it goes.
Early it was this.
This is a Ryo RA8875. This is a very cool chip. It does SPI to 40-pin TTL up to 800 by 480 resolution 16-bit. Of course, it's not super fast because SPI just isn't as fast as 24-bit parallel. But it is great if you want to just control these large displays from something as simple as a 3224 or 328. But of course, other chips work as well. And with the revision, this backlight driver got discontinued. This backlight driver. So I had to redo the board anyways. This is now a SOT 89, not a SOT 23.5. And so while I was there, I also made a couple other updates. And now I'm testing it. It's backwards compatible. So you see the touch screen and color works. And now there's a 3-state on the serial output pin as requested about a year ago. So revision coming to the Adafruit shop real soon.
All right, LadyAda, we're here at the Adafruit factory with our kiddo doing electronics at night. What's this?
Okay, hot off the wub press. This is a panel of the new Matrix Portal S3. It features an ESP32 S3 module, and there's no SAMD51. It's just the S3 driving a portal. And it's got, the Matrix, it's got headers on the back to plug directly, and also IDC on the top for a cable, but it's still the same size, USB-C, STEMMA QT, pins, level shifters, Neopix and all that. So these are gonna get tested and put into the Adafruit shops. It'll be cool. It'll be a less expensive, more powerful version of the Matrix Portal. Big upgrade.
LadyAda, what is this?
First you get the pen, then you get the tester, then you get the power, then you get the Matrix Portal S3. This is our S3 based Matrix Portal version. Got rid of the SAMD51, driving the Matrix directly, and you've got both socket and plug style connectors for the panels. And here's my tester using my RP2040 brains. I love this because I don't need to use a separate computer or Raspberry Pi. It's really fast, and it programs it over USB. And then it does like a Wi-Fi scan. It tells me to press the buttons. I press the buttons and it's like, test done. This was pre-programmed, so it only took 12 seconds. And then, if I can do this fast, remove, plug this in, and then hit reset. And one of the coolest things is that this programs in a live demo, so when people get it, it comes ready to go. It also does a Wi-Fi scan and I2C scan, so it's a good hardware test. So this is coming to the shop soon. Just wrapped this tester.
Handy.
Yes.
Bam. So was our kiddo. I clicked off of it too fast on accident. So this is the modified player. It plays prints and stuff like that. And that's the toy hacker board. What is this you're working on?
I finally got a reel of Max 31328. These are real-time clock chips that are not pin compatible, but they are firmware compatible with the DS3231. Which is kind of weird. It's like 3132 is 3231. So we'll be able to have this breakout board. It's a little bit less expensive than the DS and physically smaller. It has more capabilities. So it sounds like Maxim was like, well, we're going to keep this compatibility with this very popular real-time clock, but maybe update the process to be, a more modern process. And then this is a USB MUX chip that somebody pointed out to me. It allows you to switch between two USB ports using a GPIO, and it's electrical switching. So, used in laptops and devices, but could be a very handy breakout board. And this, coming back from 2020, this is the ICN 6211 prototyping board, originally designed with a SAMD21E18. I'm going to redo this design a little bit, but just to get started, I've refabricated it in the same layout. And it's a DSI to TTL TFT converter. So you have single board Linux computers that have a DSI port, but you don't want to necessarily program each DSI display, or maybe you have old style TTL TFT displays. You can plug this in, and this, over I2C, you tell it what the size is and the front porch and the back porch is and the H sync, and it does it for you, and also got a backlight there. So hopefully we'll be able to convert common 15-pin DSI to 40-pin TFT displays at a reasonable cost.
Top secret. Okay, we have a bunch of questions lined up. I will probably play the rest of that kiddo video with the Prince player because I was clicking fast.
Yeah.
Okay. Here we go. Ready?
Yeah.
First up, are there benefits to the RP2040 over ESP32S3 low power question mark?
Well, the RP2040 is going to be cheaper because it doesn't have all that Wi-Fi stuff, and maybe you don't need Wi-Fi stuff. In which case, the RP2040, it has that Cortex chip. There's some stuff that's only available for Cortex chips. It's It has the PIO peripheral that might be handy. There might be stuff that works with the SDK that you like. I mean, I think if you need Wi-Fi, or Bluetooth, the S3 is going to be better. But if you don't need those at all, or you're not planning to use them, the LP2040 is a low cost and a very durable chip. For low power, it kind of depends. ESP32 has lower power deep sleep, but the RP2040 has lower power run power. So it depends on when you need the lower power.
So if you want something to go to deep sleep, last a longer time, that's a different choice than if you want to just consume lower power while you're using it.
Yeah.
Cool. Okay. If someone wants to figure out, I'll paraphrase this one, what temperature the lipos discharge at, how should they figure that out?
Well, all the Adafruit LiPo batteries have a data sheet that goes with them, and they'll tell you what is the recommended charge and discharge rate and temperature range.
Okay. Someone has a modified Ender 3 Pro with a mean well 24 volt, 360 watt power supply. They are curious, can the power supply be replaced with an external power brick, assuming the power brick has the same wattage and volts as the mean well in PSU?
You can, but it's hard to find a power brick that gives you 360 watts. That's like a laptop power supply. So that's why they use a Meanwell power supply. But you can, if it died on you, you can get a Meanwell power supply to replace it fairly inexpensively, but you will have to wire it up. So, 24 volts, that you can't even get that from USB PD at the highest end. So you're probably going to have to stick with what you got, that power supply.
The next one is a good observation, not a question, but I'm going to repeat it. The new Matrix portal makes me wonder how much the part shortage of certain microchips position in the microcontroller marketplace. It seems for a while like everything was SAMD. Now it seems like there's a huge amount of RP2040 and ESP32 stuff out there. Yes.
Get absolutely. I don't know how, in production, I'm curious. I don't know.
Yeah. So, it's all connected. As we figured out, we were talking to a very well-known electronics company, and they said the way that they get their business is not the salespeople that they were paying millions of dollars to. It was the developers who were working on stuff because they were tinkering around, or they were using a chip like an RP2040, or they're using something like CircuitPython or Arduino or whatever. And that's how these things get decided, is the people who are using a lot of these things, and especially when they know about availability. So a lot of things that Adafruit does, other companies look at and say, oh, if Adafruit picked this, probably the right chip, probably the right decision. We've completely tried to get away from SAMD stuff because it's not available.
I can't get it.
And so we were like, hey, microchip.
I still really like the SAMD 21 series, but I can't get it.
Can't get it. And so that's why we have 300 plus redesign. One of the reasons 300 plus redesigns. So I think you're going to see a lot of ESP32 S3s, a lot of ESP32 out there, a lot of RP2040s. I think it's just like, why wait?
Yeah, I can't wait. I can't wait for another year.
Next up, why does from Adafruit _ text import bitmap label use so much of RAM, 11K, just import before you even display character, then 10 more bytes per character? Why does it do that?
I don't know the details. You can, post in the CircuitPython forum or ask in the CircuitPython Discord, but the text labels do quite a bit. There's a lot going on there. And with Python, you can't, it's not compile time. You don't get to really pick and choose. You have to kind of import the entire thing at once. We do different alignment, and you can have different fonts, and you can change the color and background. And so I think there's just a lot of code there that does, auto word wrapping, and you get all of that. But yeah, it's like there's this big, heavy initial import.
Okay. And then this one is in Discord. We'll do two last ones. Is the Matrix portal hanging out due to the RF produced by the Matrix panels?
It's hanging out because there is no fixed place for the connector on the back of LED matrices, and you cannot guarantee where that's going to be. So I just sort of made a reasonable size, and it already sticks up above the LED matrix, so you shouldn't have any RF interception, but each panel is a different depth before you get to the connector. It's just how it is.
You could try to do this one unless you can, and they can post in the forums, but I think there's at the bottom here.
Why is the RP2040 so aggressively priced?
Yeah. Why is it so much cheaper than a
Yeah.
Then
They are, yeah, because sorry, why the MB21 370 and the RB2040 cents? The RB2040 is a new mover, and so they're interested in being disruptive. And the definition of disruption is something that is maybe not quite as good, not quite as popular, but it's a lot cheaper. And that is a way that you usually win a market is if you can come in and you're significantly cheaper, you will win over people who, because Microchip, Atmel, ST, these are old names. Like they've been around for decades. You'll never get fired for choosing an ST processor. You'll never even get in trouble for going with a SAMD. These are well-known chips. And when Atmel was a disruptor, remember they came in with very low prices too. They were very aggressive compared to PIC, and they came with much better. You gave you more RAM, they gave you bootloader capability, they gave you USB.
then Arduino came along.
There's a lot of stuff that they went in to get you into the market. Maybe we could pull up that Cory Doctorow quote. At the beginning, they're very good to the users because they want to get users. And then eventually they're like, oh, you have to claw back that value. So Atmel Microchip is at this point in their development in clawing back phase where they will increase the prices as much as they can up to the limit of paying for developers because they want to get money for
a lot of similarities going on in the world right now with the open source software and hardware world. There's the users got you here, and then eventually you do a bunch of different things, mostly serving businesses.
Yeah.
And then people move on. Good strategy if you're running a company is make something lower cost and easier to use.
It's the disruptive way, and it works very well.
And by making something easier to use, especially in the world that we're in, is put your code out there, make it open source. If you have something that no one can do anything with, really hard to get the word out about it and get people to adopt it. Educators, they probably need something open source. If you do something closed source, it's probably really hard for them to use. So anywho, them's our questions for the night. And that's our show. Really good questions and really good observations, everybody.
All right. Thanks, everybody.
Special thanks to Takara running things behind the scenes here at Adafruit, answering customers and more. Thanks for pertinent stuff, keeping an open source hardware company going. You do have a choice. As I went over my article, you got lots of choices. Maybe pick the open source hardware ones. Because I think that demonstrates the power of this community we all built is when you vote with your feet. That's what they say. Vote for dollars. We'll see everybody next week. Thank you so much. This has been an Adafruit production. Here is your moment of Zener.
Good night, everybody.